Hello, ndikulandireni ine Cicero Chuma kuphunziro lathu lero la ratio of volumes of similar solids imene ili under similarity mu lesson 3. Tione background ya phunziro lathu lero. Lesson 1 komanso lesson 2 you covered the scale factor komanso area factor, tinaonetsera even relationship yake, and we calculated sides and area of similar figures. And mu phunziro lathu lero we are going to cover volume scale factor of similar figures. Komanso tuona kuti how is it being applied. Tikakamba za volume scale factor of similar figures, timakamba za a ratio of volumes of similar figures. Basically, that is shown by this formula here, where we are saying volume factor should be equal to volume of the image figure divided by the volume of the object. Okay, similar figures, it means kuti chinthu chinacho is just a replication of the other. Okay, titopeka chitsanzo cha munayamba mwajambulitsapo. Okay, the height that is on that picture and your height zimakhala zosafanana. Okay, but munthu umakhala kuti ndiweyo ndithu. So there is an image, your image. So the ratio of your image to you, whether it's height, whether it's width, whether it's your volume. Okay, so that ratio, it's a certain factor. So in this case we are saying volume factor, which means the volume that you are carrying, okay, and the volume that the picture or a portrait of you, the ratio of that gives you volume factor. So volume factor is given as volume of the image figure divided by volume of the object. Let's look at an example. We have here this example that's saying a volume of a container. Okay, so we have a volume of a container A. So container A has got a volume of 300 cubic centimeters. Okay, and the volume of container B has got a volume of 150 cubic centimeters. Given that container B is an enlargement of container A, which means B is just an image of the container A. So they're saying find the volume factor. So volume factor in this case will be equal to the volume of the image. We can say image volume of image divided by volume of object. Okay, so that's that. In this case our image is 150 cubic centimeter divided by 300 cubic centimeters. So centimeters will go, and 150, that's 1/2. So volume factor, that is volume factor. So our volume factor is found as 1/2, and this one can as well be written as 1 to 2. Okay, that's our volume factor for this problem. So now let us look at the relationship that is there between volume scale factor and the scale factor itself. So for us to understand the relationship between volume scale factor and scale factor, I'll use a demonstration. Okay, we'll consider simple stuffs. Okay, let's say we have something like, let's say solid 1. Okay, we might have solid 1. In this solid 1, it's a cube. Let's say it's a cube. Let me put it up. Could be that. Right here. Okay, so could be this side too, and this, it could be 2 height too, and that side too as well. Okay, so for this one, we know that it has for that cube, it has length of 2. Okay, length, okay, let's just put it like this. It has length as 2, and it has volume. Okay, so it's base times height. So 2 times 2, 4 times 2, that's 8. Okay, that's 8 cubic centimeter. And now we might have another solid. Okay, let's have that solid. Okay, let's have that solid. Maybe this solid, we'll make it similar. We can just do it 4, 4. Okay, that's a cube for 4, 4. And this one, it has length, you see, that's 4 centimeter square. And the volume of that, it will give you 4 times 4, that's 8. 4 times 4, 16. 16 times 4, that's 64 cubic centimeters. Okay, so I'll not do, you can do as much as you can. For today, for the sake of this and with time, I'll concentrate much on this too. Okay, so from the definition, we said that volume scale factor is the volume of the object divided by the volume of the, the volume of the image divided by the volume of the object. Okay, in this case, for these two similar figures, we know that volume scale factor, VSF, volume scale factor, will be equal to volume, that is, let's say this is the main object and that is the image. Okay, so to make it simple, so we say 8 cubic centimeter divided by 64 cubic centimeter cubes will go. So in this case, you will now remain with 8 into 64. 8 times 8, that's 64. So it will give you that. Okay, so if you look at Akuluawa, okay, and if we find the scale factor, okay, now let's find the scale factor. Scale factor, that's a volume scale factor. Now this is just a scale factor. Scale factor in this case, it will be that image divided by that object, which is 2 over 4, and that will be 1 over 2. Okay, so but the relationship above. Okay, let's now, okay, to do that, just to have more space. Okay, we have 1 over 8 and 1 over 2. Okay, you will see that 2, or we can say 8, you can as well write 8 as 1 over 2 to the power 3. Okay, even 1, we can as well say that it's 1 over that to the power 3. Okay, so there's that relationship. Okay, if you have a scale factor, you just cube that, it will give you volume scale factor. Yeah, you just do to the power, yeah, cube that, it will give you volume scale factor. And if you cube root volume scale factor, it will give you scale factor. We will demonstrate this more in an example. Okay. From there, as I've already said, we have discovered that the volume of similar solids is the cube of the scale factor. Okay, the volume factor of similar objects of similar solids is the cube of the scale factor. Okay, so we are saying that volume factor is the same as to say scale factor but to the power 3. Or you can say that scale factor is the same as to say cube root of volume factor. That's the relationship between these two. So let's look at an example and see what we're trying to say. In this example, we are saying that calculate the ratio of volumes of similar cylinders of diameter 6 centimeters and 9 centimeters. Okay, let's say let volume of smaller cylinder to be equal to x cubic centimeter, and the volume of that bigger cylinder, we should relate it to be a cylinder. We can relate it to be y cubic centimeters. Now, the question is calculate the ratio of volumes of similar cylinders. The ratio of volumes is the same as scale factor, volume scale factor. Okay, so we can as well just use what we have shown. We know that we can say that, but scale factor will be equal to, in this case, we consider 1 to be our image, so the larger one and the small one will be our image. In this case, we'll just go by that. Okay, so the smaller one, we're saying the scale factor will be 6 over 9. Now, volume factor, or which we can as well write as 6 to 9. It's the same stuff. Okay. Therefore, using the formula that we have shown, we know that volume factor or volume scale factor will be equal to the scale factor, which is 6 over 9, but in this case it has to be cubed, so it will be 6 to the power 3 over 9 to the power 3. Okay, which is the same as to say 6 cubed to 9 cubed. Alright, so you can simplify that. If you simplify that, you should get 8 to 27. 8 to 27. That's the ratio of this. 8 to 27. Okay. That's the volume factor that we want from there. Let's look at another example. In this case, they're saying we have two spheres which have volumes in the ratio of, so this is we can say volume factor to be equal to 64 over 125. Okay, it's the same as to say that. That's the volume factor. Now the question is, what is the ratio of their surface areas? What is the ratio of their surface areas? We first of all need to find the area. We first of all to find because for us to find the area, in this case, you need to bear in mind that there is surface areas, but our ratio is between scale factor and volume, which means we have to first of all find the lengths, the sides. After finding the sides, then we'll find the scale factor. After finding the scale factor, we can relate that scale factor to the area factor. So we'll be able to find the ratio of the area factor, which is the ratio for their surface areas. Okay, so in this case, scale factor from our definition will be equal to cube volume factor, cube root of volume factor, which will be equal to the cube root of 64 over 125. Okay, so this one is the same as to say cube root 64 over cube root 125, which will be equal to cube root of 64. We need to find that. So on your calculator, cube root of 24 will be equal to 4, and cube root of 125 will be equal to 5. Okay, which is the same as to say 4 to 5. Okay, so this is our scale factor, but they want us to find the area factor, the surface areas, the ratio of the surface areas. They want to say the area factor. So, but we know that area factor from previous lesson, area factor is the same as to say scale factor to the power 2. Scale factor to the power 2. So what is our scale factor? Our scale factor is 4 over 5 to the power 2. So the same as to say 4 squared over 5 squared, which will be equal to 16 over 25, or 16 to 25. Okay, so this is our area factor. Please, we need to be together on how we are finding this. Don't just memorize, but know where these things are coming from. Then let's look at this problem. In this one, they're saying two similar cylinders have their radii. In this case, we have two similar cylinders whose radii is 1 to 2. In this case, this is a length. It's It's just a scale factor. We can say scale factor of this one is equal to 1 to 2. If the smallest cylinder has that volume, calculate the volume of the larger cylinder. It's obvious the larger cylinder has got a larger figure. The smaller cylinder has got a smaller figure. So that's that. In this case, we are talking volume now. Now we need to find the ratio of the volume now. But we know that, okay, this one, the same as to say 1 over 2. We need to complete that. So we know that the volume factor is the same as to say is equal to scale factor part to the power 3. Okay, that's that. Right. So in this case, for us to find volume factor, we need to cube our given scale factor. So in this case, the smaller cylinder, in this case that is the smaller cylinder, here the volume of the, okay, so in this case it's 1 to 2, so smaller cylinder is 21.56 centimeter cubed, okay, divided by the larger cylinder, which we don't know, larger cylinder, which we don't know. This one should be equal to scale factor part cubed, whereas our scale factor is 1 over 2, but that one should be cubed, okay, according to our formula. Okay, so in this case, you say that 1 to the power 3, that's 1. 2 to the power 3, that's, I think, 8. All right, so in this case, you just cross multiply, you find out that you have larger cylinder times 1, you have, that's larger, just larger cylinder. Larger cylinder should be equal to, in this case, it will be 21.56 centimeter cubed multiplied by 8. This one will give you, I think that's I think it's 172.8. Just a moment. Yeah, it will give you 172.48 cubic centimeters. Okay, so that's the volume of the larger cylinder.